Okay, so in this video, we'll be discussing the paper 3 for year 2023, October, November, paper 3. So let's have a look for question number 1. Okay, so they are given us the inequality that involve the modulus function. They want us to find the value of x that satisfy this one. So when we are having the modulus function inequality, right, on the other side is the number, you can use a general formula to expand the modulus function, where you should know that modulus x is smaller than a. It can be expand become x is between negative a until positive a, where a is the value lah. Alright, so same thing happen for here. Here we are having an inequality with the x function x inside and then smaller than the value a, which is 0.5. Therefore, you can expand it as well. So what do we have here is I'm having 2x plus 1 minus 2 modulus smaller than 0.5. Okay, so first of all, I want to remove the modulus form. So I will have exactly the same function in the modulus, and then it is between the value of negative 0.5 until positive 0.5. Okay, then I want to slowly move all the terms to the other side so that my center here, the center part here, I'm having the x only. So I slowly move it. So now, first of all, I add every single part here, this part, and also this part by plus a 2. Okay, adding a 2 for every single part here. Right, so negative 0.5 plus 2, you get 1.5. And then for this part, negative 2 plus 2, you're having no more, right? So you're left only 2 power x plus 1. Then 0.5 plus 2, you're having 2.5. Okay, so for your information, x power x plus 1 can be written as 2 power x. 2 power x plus 1 can be written as 2 power x multiplied with 2 power 1. And next step, I want to move the 2 power 1 over. That means for every single part here, I try to divide everything by 2. So if I divide everything by 2, this part I'm having 0.75. So the center part here, I'm having 2 power x. Then 2.5 divided by 2, you're having 1.25. Okay, so next step, I want to try to think a way to make the x can be pulled down, become the number. Right, so I will take ln for all the part for the inequality. You can take log also if you want. So if you want to take log base 10, then basically you take everything with log. So for me, I'm going to use the ln. So no matter you use ln or log, basically they should be the same. So if I take ln for every single part here, I'm having x ln 2, then ln 1.25, and also ln 0.75. Then the last step here, to know what's the value of x or what's the range of x, so you take ln 0.5 divided by ln 2. So every part you divide it by ln 2. So ln 1.25 divided by ln 2. Okay, so try to use calculator a little bit to help you so that you can get the final value. Correct to 3 significant figure, my answer is negative 0.415. And also for the right hand side here, I'm having this 0.322. Correct to 3 significant figure. Right, so this is how we solve this inequality lah. Okay, but of course, at the beginning, you need to know, right, how can you expect a modulus x smaller than a? So generally, it is between, x is between negative a until positive a. So using the same concept, this is how we solve the inequality. Okay, so question number 2. They want us to sketch on an Venn diagram and also shade the region that fulfill the two inequality of complex number. So this is what we have the first one. Okay, so before I start to draw the graph, right, or maybe to draw the complex number z, the locus, so I need to change it, become the pattern z minus a complex number smaller equals to z minus another complex number. Okay, so for this part, if I want to have z minus a complex number, right, so my complex number here should be 1 minus 2i. So that you try to imagine, if let's say you multiply the minus inside, then you are getting exactly what we have, z minus 1 plus 2i here. Alright? Okay, so I have to rephrase it into this pattern before I can sketch the locus. Right, so this is what I have. And then for the right hand side here, I'm having a modulus z. So modulus z basically means that you're having z minus 0 plus 0i. Okay, so for this inequality, Basically, it is the perpendicular bisector between the point 1, -2, and also the 0, 0. Alright, so this is something that you should know about it, the basic of the pattern for the complex number, right? So both sides got inequality, basically, both sides got modulus function. Basically, it is a perpendicular bisector for these two complex number here. Alright, so maybe you can start drawing now. So I'm having 1, -2, 0, 0. So you need to try to measure the scale, okay, for the x and also the y axis. Okay, so maybe what I try to do is like I try to label them. This is 1, this is 2, so on. Okay, then I'm having this which is -1, -2. Okay, so this is the imaginary part, this is the real part. Okay, so I have to plot 1 and -2 first. So where's the point 1 and -2? By right, it should be somewhere here. This is 1 and also -2. Okay, so I hope that you can see this. This is 1 and -2. And after that, I have to plot the point 0, 0. So this is the point 0, 0. Okay, so how to sketch or how to draw a perpendicular bisector for this point? Okay, so to draw a perpendicular bisector, the midpoint will be at 0.5 and -1. So this is the 0.5 and -1. Okay, this is 0.5 and -1. So if you have a look for the gradient between these 2 points, right, 0, 0 and also 1 and -2, the gradient is basically -2. Okay, the gradient is basically -2. So this gradient is equals to -2 lah. So if you want to draw a perpendicular bisector, so the perpendicular bisector should have the gradient 1/2, so that when you multiply these two gradient together, it is equals to -1, right? Perpendicular bisector ma. So perpendicular line, the gradient will be slightly different, right? Okay, so original line multiplied with perpendicular line gradient should be equals to -1. So from here, I know that my gradient of perpendicular line should be half. So the half here means that if your y moving for if your y moving for 1 unit, then your x need to move for 2 units. Okay, so please have a look for this point, yeah. If I want to move my y go up for 1 unit, that means at the same time, your x needs to move to the right hand side for 2 unit. So 2 unit means that this is 0.5 plus 2, you have 2.5. That means all your perpendicular bisector line will pass through this point. Okay, so if you try to calculate the gradient, it should be equals to half lah. Okay, yeah. So some students, they might not want to use this method to try and figure out the line, or maybe they will use some other method, like maybe they use the protractor, right, to measure the angle also can, up to you. Or maybe you are using the ruler to help you and draw them and put them into 90 degree also can. There are many different ways, right? So for me, I'm trying to connect these 2 points together. So by right, I'm having this. So I try to join them together, yeah, these 2 points. So this is basically the perpendicular bisector for the point 1, -2, and also 0, 0. Okay, so I try my best to draw a straight line here. Okay, so this is 90 degree. Right, so basically this is what we have for this particular inequality in modulus sum. Alright, so I want to try the other one. So for the other one, I'm having modulus z minus 2 smaller equals to 1. So to sketch modulus z minus 2, I need to rephrase become z minus a complex number smaller equals to 1. Okay, so what is this particular complex number here? So to get back z minus 2, by right I'm having 2 plus 0i here. So that when you multiply the negative inside the basic, the complex number, right? So you are getting back this modulus z minus 2. Okay, right. So I might rephrase it into this form so that I know what's the center of the circle. By right, this one side got modulus, the other side have no modulus one. The locus is actually a circle. So the center will be 2 and 0, and then the radius will be a 1. Okay, so let us have a look. Center 2, 0 means this point. Then the radius is 1. That means the circle will pass through this point, this point, then here, and also here. Of course, for in exam, if you want, you can try to use a coin or maybe something, some tools to help you to draw a nice circle. Okay, so for me, I just try my best to plot it lah. So assume that I'm having a nice circle here. Okay, so the green color one is actually the second inequality where z minus 2 plus 0 is equals to 1. So now we have to shade the region. Okay, if I want to shade the region, right, when you're having a circle, but it is smaller equals to 1, that means all the points inside the circle will be included in your consideration. Okay, and after that, for this point, okay, so for this inequality, they are saying that the distance from z to 1, negative 2 is less than the distance from z to 0 and 0. So for your information, the z can be anywhere, right? So maybe on this particular dotted line, if I try to plot any point closer to 1 and negative 2, this is the point closer to 1 and negative 2, right? And let's say this is my z. So the distance from z to this point is smaller than the z to 0, 0. I think it's quite obvious, right? Okay, so which means that we are going to shade the area below the whole part of the line. Okay, so they are asking for the area that fulfill both of the inequality. Therefore, you see where is the overlapping area for these two inequality here. So by right, it should be the area below the line and also inside the circle, right? So my final answer for the shaded region should be this particular part. Okay, so this is a shaded, the region that fulfill the two inequality shown in this question. Alright, yeah, so this is how we solve question number 2. We are now at question number 3. We are given a complex, oh sorry, not a complex number, a polynomial, right? And then denoted by px, this is a polynomial. And then they say when px is divided by x plus 2, you get the remainder negative 38. When it is divided by 2x minus 1, then the remainder is 19 over 2. So by using these two information, they want us to find the value for a and also the b. Okay, so for this question, they give us the factor, oh sorry, not the factor, the divisor. So they give us the divisor. At the same time, also they give us the remainder. Alright, so to find out the value for a and b, right, there are a few methods that you can use. Either you can use a long division, then you try to solve a and b, or if you want, you can use the remainder theorem. So remainder theorem means what? The remainder theorem means that when you try to substitute the value of x from the divisor into the polynomial, then by right, you will get the remainder. Okay, when you put the value of a into the polynomial. So this is what we have for the remainder theorem. Alright, so I'm going to use this one. To me, I think this one is more straightforward. Some students might want to use a long division also can, no problem at all. Alright, so now let's have a look for the first information here. They are saying that when the polynomial is divided by x plus 2, so the remainder is equals to negative 38, which means that if I want to substitute negative 2 inside the polynomial, I'll get the remainder equals to negative 38. So you can see that I'm using this one. How I get the negative 2? So you can try to assume that divided by x plus 2, right? So you let it equals to 0, therefore you get x equals to negative 2. So this is how the negative 2 come from. Okay, then substitute negative 2 into your polynomial. Okay, so substitute negative 2 into all your x in the polynomial here. So by right, I'm having 2, then with negative 2 power 3, then a, negative 2 square, then b, negative 2, and also plus 6, it is equals to negative 38. So do a little bit of calculation here. You're having negative 16 for the first term, then 4a for the second term, minus 2b for the third one, and also plus 6 equals to negative 38. By right, from this part, right, if you try to simplify all your terms, you have 4a minus 2b equals to negative 28. And further simplify, you are having b equals to 2a plus 14. And I will treat this as a first equation here. Right, And after that, let's continue with the second equation. So for second equation, I want to form it by using this one. When polynomial is divided by 2x minus 1, so the remainder is 19 over 2. So the same, I will apply the same remainder theorem here lah. So substitute x equals to half into the polynomial, then I'll get the remainder 19 over 2. So this is what we have. Okay, so I'm having 2, then power 1 over 2 power 3. Okay, 1 over 2 power 3, and then plus a, then 1 over 2 square, plus b, 1 over 2, plus 6. It is equals to 19 over 2. Okay, of course you need to use calculator, or maybe you need to do some calculation here. Then this is what you get, 1 over 4 plus 1 over 4a plus 1 over 2b plus 6 equals to 19 over 2. Then please kindly simplify your equation further. I'm having half b equals to 13 over 4 minus 1 over 4a. Right, and I will treat this as the second equation. So next, what are you going to do now is we are trying to solve the equation simultaneously. So you can substitute equation number 1 into equation number 2. Okay, so this is what I'm going to do now. So substitute equation number 1 into equation number 2. Okay, so I'm having half b. So b is 2a plus 14 from equation number 1 equals to 13 over 4 minus 1 over 4a. Okay, and then you slowly simplify it. And if you didn't do careless mistake, right, then by right you should get the value of a lah. Okay, so just double check and see whether you got what I show you here or not. So 5 over 4a equals to negative 15 over 4. And from here, you get your a successfully, which is equals to negative 3. So once you get a equals to negative 3, then either you substitute into equation number 1 or equation number 2 to get the value of b lah. So for me, I'm substituting into equation number 2. No matter which equation are you substituting, by right, the answer for b should be the same, yeah? It must be the same. So b will be equals to 8, if you didn't do any careless mistake here. Alright, so this is how we solve question number 3. Okay, so let's discuss question number 4. They want us to solve the quadratic equation for this one and then giving an answer in the form of x plus yi, where x and y are real. So they give us a very obvious hint. This is a quadratic equation, but in your quadratic equation, right, your final answer should be in a complex number form. So that means this is a w here. The w here will be actually the complex number, yeah. Okay, so to solve for quadratic equation, definitely for this kind of equation, you cannot factorize it. So what are we going to do now is we're trying to use the formula for quadratic, to solve for the quadratic equation, where to get the x or to get the w, it is equals to negative b plus minus square root b square minus 4ac divided by 2a. Okay, so this is what we are going to use here. And again, we need to know what is a, what is b, and what is c. So a will be the 3 plus I, which is the coefficient of w squared. B will be the coefficient of w, which is negative 2. And c will be the constant term, where it is 3 minus I. Alright, so this is what we have for a, b, and also the c. Okay, so we want to apply this in our equation here to get the w. So w is equals to negative b plus minus b square minus 4ac. So b square is negative 2 square minus 4. Then a is this 1, 3 plus I. Then c is 3 minus I. Okay, then divided by 2a. So 2 multiplied with 3 plus I here. Okay, so of course you can try to simplify them. Right, so to simplify the term here, negative 2 become positive 2 lah. So plus minus negative 2 square, I'm having a 4. Okay, so minus 4, I just try to copy it first. I want to expand this bracket inside the square root. So if I want to expand this bracket inside the square root, 3 times 3, you get a 9. Okay, then I times I, you get negative I squared. So negative I squared basically is a negative I square, negative I square. Okay, so I square is negative 1. So you're having negative 1, which is a positive 1. So it becomes 9 plus 1. Then plus 3i minus 3i will cancel off each other. So our bracket here, after you expand, you're having 9 plus 1 times 4. Then divided by 2 times of 3 plus I. Okay, I want to simplify the term in the square root, and that gives me negative 36. Okay, then divided by 2 and then 3 plus I. Okay, then for negative 36, yeah, you can make it become negative. You can take it becomes 36 multiplied with negative 1 square root. So square root 36, you'll get a value. Square root negative 1, it is actually a I. Okay, so if you try to simplify what we have here, right? So by right, you're having 2 plus minus square root. Okay, I should write it like this. 36, square root 36 is a 6. Okay, square root 36 is a 6. And then square root negative 1 is an I. So you're having 2 plus minus 6i divided by 2. Then 3 plus I here. Okay, next step. For the terms on top, right, the numerator, you can factorize out the 2. If you factorize the 2, you simplify with the term at the bottom. So by right, you're having 1 plus minus 3i divided by 3 plus I. After you simplify the 2 on top and also the bottom. Okay, right, then after that, what we're going to have here is we are going to separate them. So I'm having 2 answers for this part. I actually have 1 plus 3i divided by 3 plus I. Another one would be 1 minus 3i divided by 3 plus I. And of course, we can't leave our answer in this pattern because they are requesting for x plus yi. So to make it become x plus yi, I have to rationalize my fraction. How to rationalize the fraction here? Okay, so you have to multiply the conjugate of the complex number on top and also the bottom, where you have to multiply it with 3 minus I and also 3 minus I. Same thing happened for the second set of the answer. So 1 minus 3i divided by 3 plus I, right? You have to multiply it with 3 minus I, top and bottom, so that you can rationalize your answer. Okay, then let's discuss and simplify it. So 3 multiplied with 3, you have a 9. Okay, then 3 multiplied with negative I, you're having negative 3i. Then I times 3, you're having positive 3i. So just now got negative 3i plus positive 3i, they cancel off each other. Then you take I, multiply with negative I. So you're having negative I squared. So again, when you write negative I squared, it means that it is actually negative multiplied with negative 1. So negative 1 become positive 1. So end up for your step here, you're having 9 plus 1. Okay, then the next one also the same. For numerator, you are having 3 minus I, then 9i plus 3. Okay, so this is what I have after I multiply everything together. Then same thing happen for the second fraction. So at the bottom, I'm having also 9 plus 1. Then for top, I'm having 3, okay, minus I, minus 9i, then negative 3 times 1, you are having positive 3i squared. So positive 3i squared means positive 3 times negative 1, you still have negative 3. Okay, then further simplify our term here. By right, I should be having 6 plus 8i divided by 10. And also for the second term here, I'm having negative 10i divided by 10. So further simplify and separate them, I'm having 3 over 5 plus 4 over 5i. So that my answer can be in the form of x plus yi, right? Okay, then for this part, negative 10i divided by 10, I'm having negative I. So if you want, you can write as 0 minus I, or you can just write as negative I. So after simplifying my answer, this should be the final answer in the form that they want, which is x plus yi form. Okay, alright, so you just need to take note that for this kind of question, for this particular quadratic equation, when you want to solve it, you have to use the quadratic formula. That's the first thing. And after that, don't forget about the I square. Okay, so wait, yeah, recall. So what do we have for I square here? I square means equals to -1. And also, if you're having square root -1, you know that you can rephrase it become I. Alright, so I think all these are some important details, or maybe the small details that you need to know when you want to solve the question throughout. So in the steps, you might need to apply these two important formulas here. Right? Okay, so this is how we solve question number 4. Okay, so question number 5. They want us to find the exact coordinates, so highlight the keyword exact coordinates and then stationary point of the curve for this one. Alright, so when you are looking for stationary point, basically you have to find out the dy dx and you let them equals to 0. So when you let dy dx equals to 0, you will get the x. Then after you get the x, you can get the y coordinate, and that's how you find out the coordinate for the stationary point. Alright, okay, so let's start with our fraction here. We are having a fraction, the equation in terms of fraction. Alright, so to differentiate it, I'm going to use the quotient rule. Right, so the quotient rule is, if let's say y equals to u over v, then to get the dy dx by using quotient rule, the formula is v squared at the bottom, then you copy the v, differentiate the u on top, then minus, now you copy the thing on top, differentiate the v at the bottom. Okay, so this is generally what we have for this part. So I'm using the quotient rule here. Alright, so if you're not able to memorize this one, basically you can still refer to the formula booklet. It is actually provided in the formula booklet as well. Okay, so we'll start with this one. If I want to find the dy dx, right, I want to square the denominator. So to square the denominator, I just put 1 minus x squared, then with a square outside. Copy the term at the bottom, so I just copy what you have at the original bottom, not the after the differentiation one. The original bottom, 1 minus x squared. Differentiate the numerator on top. So how to differentiate e power 3x squared minus 1? So to differentiate e power 3x squared minus 1, you copy the original thing. Then you imagine how you differentiate the power. Differentiate this one, 3x squared minus 1. What do you get? You will get 6x. Okay, so you multiply with the 6x after the differentiation. Okay, so I will put it here. So differentiate this whole thing, I'm having e power 3x squared minus 1, then multiply with 6x. Okay, so I complete the first part. Now I want to minus. Okay, so just now is I copy the bottom, differentiate the top, right? And now I want to do it the other way around, where I want to copy the top, differentiate the bottom. So if I try to copy the top, I'm having 3x squared minus 1. Okay, so I copy the top. Differentiate the bottom means you want to differentiate 1 minus x squared. How you differentiate 1 minus x squared? Differentiate 1, you get a 0. Differentiate negative x squared, you're having negative 2x. So I multiply it with the original bracket on top, multiply with the differentiation of the bottom. So you're having this, something like this. Okay, then next, before I can solve the equation, I need to try and simplify or factorize out my fraction first. Okay, I will be having e power 3x squared minus 1. If I factorize out e power 3x squared minus 1, right, I'm having 1 minus x squared in front. Oh, I need to times 6x, then plus 2x. Okay, so negative and negative become positive, alright? Okay, then the e power 3x minus 1 has been factorized out. Okay, divided by 1 minus x squared squared. Okay, then for this part, it seems that I can further simplify it. Okay, so if I want to further simplify it, then I will be having 6x minus 6x power 3 plus 2x. Then divided by 1 minus x squared, then squared. Okay, further simplify again. 6 plus 2 is an 8, then minus 6x power 3 divided by 1 minus x squared, then squared. Okay, alright, so I will let dy dx equals to 0. So 0, 0, 0 here. And from this equation, I want to try to solve for this equation. The denominator, move it up, become nothing. So for the terms on top, right, I have three equations here. 3x squared minus 1 equals to 0. That's the first thing. And then I'm having 8x minus 6x power 3 equals to 0, right? But of course, the 8x minus 6x cubed, right, you can still factorize out something. So you can still factorize out the 2x. When you factorize out the 2x, you're having 4 here, then minus 3x squared. Okay, yeah, so this is something that I have. So from here, I try to solve for the equation. If I want to solve for the e, right, if I take ln both sides, ln 0 will give you a math error. Ln 0 here will give you a math error. Therefore, we ignore the answer for this part. That means I cannot get an answer. There's no solution for this part. Okay, then from this equation, you are having 2x equals to 0. And also 4 minus 3x squared equals to 0. So from here, you are getting the x equals to 0. Then for the other equation here, you are having x equals to plus minus 2 square root 3 over 3. Okay, so by right, you should have 2 over square root 3 lah. Because 4 over 3, right? So 4 over 3 will be 2 over square root 3. How can I change it become 2 square root 3 over 3? You have to rationalize it if you want. So you multiply with sub 3 and sub 3. So when you multiply everything together, so this is how you get the 2 square root 3 sub 3. For those who are using ES calculator, when you press the calculator directly, you can get an answer. But for those who are using MS calculator, Casio MS calculator, then basically you have to do some extra step for rationalization. Okay, yeah, so this is what we get. Okay, then after that, they are asking for the exact coordinates. So that means besides the value for the x, I also want to get the values of y. How to get the value of y? We go back to the original equation. So I can get the y by using this original equation here. Okay, yeah, so let's start. Now I'm having 3 value x, x equals to this one, then x equals to the other 2 value here. So I will start with x equals to 0 first. When x equals to 0, what happened to the y? So my y equation is, they will become e power 0 minus 1. So e power 0 minus 1 will give you e negative 1. Then divided by the bottom. So what's the bottom there? Bottom should be 1 minus x squared. So 1 minus 0 squared, you're having a 1. Therefore, your y, you are getting 1 over e power 1. Okay, so that's your first coordinate. So you just keep it in the e form because for this question, they are requesting for exact coordinate only. Alright. Okay, then the second value, we are going to use x equals to 2 sub 3 over 3. How to get the y? So y equals to e power 3 x squared. So x squared, you should get 4 over 3, right? Minus 1. Divided by 1 minus x squared also, right? So 1 minus x squared also, you are getting x squared is 4 over 3. Okay, so all these are the value after I square it. So from here, you'll get e power 3 on top divided by negative 1 over 3 at the bottom. So if you simplify, it will become negative 3e power 3. Then for the last point, we are trying to substitute x equals to negative 2 over 3 times square root 3. So the same thing happened here. Okay, e 3x squared. What's the x squared here? Still 4 over 3 minus 1 divided by 1 minus x squared. Again, so what's the x squared? Substitute this value inside. This value x squared, again, you are getting 4 over 3. Then when you simplify it by right, you get the value which is also the same. E power 3 on top divided by 1 over 3 negative. Then simplify become 3e power 3. Right, so we have successfully found out the coordinates for all the stationary points. There are 3 stationary points here. So as the final step, I will strongly suggest you to put them in the coordinate form. So what are the stationary points that we have? Okay, so the stationary points that we have here, there are 3. One is 0, 1 over e. One is 2 sub 3 over 3 with negative 3e power 3. Then another one would be negative 2 square root 3 over 3 with negative 3e power 3. So these are the 3 coordinates for the stationary point that we have, right? So we can stop here, no need to further and decide which one is maximum, which one is minimum, because the question didn't request for it. Alright, yeah, so this is how we solve question number. Okay, so we are now at question number 6. Right, so they want to show the equation, right? This particular equation. We have the cotangent square, we have cos 2 theta equals to 4. So this whole equation can be written as the equation in this form. Alright, so this is where we need to start and then we need to lead to this final answer. Alright, so let's have a look for the final answer first. Yeah. So for this final answer, you can see that generally everything is in terms of sign. And also the number only, sine theta here, right? Okay, they are only in terms of sign. Then the data also, everything is about single data. Single data. In our question here, we're having 2 data, which is a double angle. So the single data here means it's single angle. So our final answer here must be rephrased into the equation in terms of sine with the single data, right? Single angle. So we can slowly adjust our steps or maybe our solution into the answer that they want. So first of all, try to expand or try to rephrase the cotangent square theta become something that's related to sine. So for cotangent, it is 1 over tangent. Okay, so cotangent theta is equals to 1 over tangent. And 1 over tangent means 1 over sine over cos. And that's why it can be written as cos over sine. Okay, so cotangent square, it can be written as cos square theta over sine square theta. Okay, after that, 2 is a constant, I just copy it. Now let's have a look for cos 2 theta. This is a double angle, right? So for double angle cos 2 theta, trying to link it with something that's with the sine. So if you can't really remember, then of course you can refer back to the formula booklet provided. Double angle formula for cos 2 theta, there are 3. So I want to take the one that involve only the sine square or sine. So I think this is what we want to use, right? Okay, so that's why it is quite important for you to know, okay, what is the direction that you need to go. So for the double angle formula of cos 2 theta, we are going to use the expansion that involve the sine only, where cos 2 theta equals to 1 minus sine 2 sine square theta. Okay, so for this particular step, this is what I want to substitute, 1 minus 2 sine square theta, and then it is equals to 4. Okay, right, so the first step, this is what we are doing now. And then next one, for cos square on top, right? For cos square on top, you can also change it become 1 minus sine square. This is another identity that we learned earlier in AS labels. Okay, so for this step, we are using cos square, sine square plus cos square equals to 1. Okay, then plus 2 minus 4. Sine square theta equals to 4. Yeah, so you can see from here, basically every terms in our solution already got the sign and also the number. There's no other trigger like cos lah, tangent and whatsoever. So what are we going to do now is we should slowly rephrase them. Multiply every single term, okay, with the sine square. So 2 multiply with sine square, I'm having 2 sine square theta.
4 multiplied with sine square, 4 sine square multiplied with sine square, you're having 4 sine power 4 theta, then equals to 4 sine square theta again. Okay, so this particular step is mainly to get rid of the denominator lah. Alright, so that's why you multiply the whole equation, okay, with sine square. Okay, so next, what are we going to do now is, we try to rephrase everything over, and I want to make the 4 sine power 4 theta as a positive value, then 4 plus 1 minus 2, so 4 plus 1 minus 2 is a 3, right? Yeah, so I'm having 3 sine square theta, then minus 1 equals to 0. Okay, so this is how we show the equation that they want us to show. Alright, then let's continue further to part number B. So for part number B, they want us to solve this particular equation for the theta between 0 and 360. So if you try to observe this equation, right, it is what we have in the part 1, where they want us to prove the equation can be equals to something in sine. So they already give us a very obvious hint to solve this equation. That will be the easier way. So directly, I'm going to use the result from first part, yeah. So from part number A, we are going to use the results directly from part number A. So what do we have in part number A? So we are having 4 sine power 4 theta, okay, plus 3 sine square theta minus 1 equals to 0. So by right, this is actually a quadratic form equation in terms of sine square. Alright, if let's say you're not able to observe it, for those who are not able to observe it, maybe you can let y equals to sine square theta first. Okay, where if you rephrase sine power 4 theta, it is sine square theta square plus 3 sine square theta minus 1 equals to 0. So you are having 4y square plus 3y minus 1 equals to 0. So basically, this is a quadratic form equation. Alright, so for me, I will not rephrase it become the equation in terms of y. I want to directly factorize it from here. So I can factorize it successfully into 2 brackets. So I'm having 4, then this is a 1. Oh, sorry, this is a 1, this is a 1. So I want to have a positive 3. So I'm has positive 4 sine square theta. Okay, then this one should be sine square theta also. Then this one should be minus. Okay, then from here, if I try to simplify or solve this equation, I'm having sine square theta equals to 1 over 4. Then sine square theta equals to negative 1. Okay, so this part, of course, we can't solve it out because if you take square root for negative 1, there's a math error. So we're not able to solve this particular equation here. And we'll continue from this part. So if you continue from this part, taking square both sides, you are going to have plus minus 1 over 2. Okay, so for plus minus 1 over 2, we have to go through the quadrant, and then we want to accept the answer, okay, for all the quadrants where sine is positive or sine is negative. So the basic angle for sine half is 30 degrees. Okay, so if you have looked for the data here, it is stated from 0 until 360. That means that you want to go through the quadrant you have to go through the quadrant, the 4 quadrant. So the first quadrant is everything positive, second quadrant sine positive, third quadrant is tangent positive, fourth quadrant is cos positive. So to get the answer from the quadrant, first quadrant is the basic angle, second quadrant is 180 minus theta, basic angle, third quadrant 180 plus basic angle, fourth quadrant is 360 minus basic angle. So I already know my basic angle is 30 degrees, right? So I need to go through all the 4 quadrants to see which answer that I want to accept. We are considering the sine positive and also sine negative, yeah? First quadrant sine is positive, therefore I want to answer from there, which is basic angle. Second quadrant sine is also positive, I want to accept the answer from this part also. I will take 180 minus the basic angle 30, so I get 150. For the third quadrant, tangent is negative. So in my solution here, you also want to consider the answer from tangent, sine negative. So this quadrant sign is negative, right? So to get the answer from this quadrant, I take 180 plus 30 degree. So 130 plus 30 had 210. And next, for the fourth quadrant, cos is positive, that means sign negative. Again, I want to accept the answer for sign negative. So to accept the answer for this quadrant, you take 360 minus 30 degree. Therefore, you're having 330. Alright, so if you go through for another round, then the answer will be exceed 360 degree. So I think should stop here. Alright, so for this question, we are having 4 answers for the data, where it should be 30, 150, 210, and also 330. Okay, so this is how we solve question number 6. Alright, so we are now at question number 7. We are given an equation of the curve can be written like this, and then very obvious you can see that the y and x cannot be separated very clearly, where you cannot express the equation y in terms of x. Alright, so this is an implicit function. Then they want us to show that dy dx equals to this phrase, okay, this fraction. So basically, you need to involve, to get a dy dx, we have to involve the implicit differentiation. Alright, so we have to differentiate term by term, and then you try to group the dy dx at one side. Okay, so let's start with our original equation first. This is our original equation, x power 3 plus y squared plus 3x squared plus 3y, and it is equals to 4. Okay, so we differentiate term by term, differentiate x power 3. So differentiate x power 3 will be having 3x squared. By right, you should write dx over dx. Alright, because we differentiate x in terms of x with respect to x, so you write dx over dx. But dx over dx is a 1, so usually we don't write it out. And then for the second term, we are having y squared. So differentiate y squared, you have 2y. Okay, the differentiation technique is the same, right? So differentiate y squared, you're having 2y. And now, because we are differentiating y in terms with respect to x, so what you need to do is you have to write actually dy dx at the back. Okay, so for x also, we actually need to write dx dy x1 because dx over dx is a 1, so usually we don't write it out. But for y, you have to write dy dx because it is not a 1, right? So you have to write out purposely, right? Then for 3x squared, so 3x squared, if it's differentiate, you're having 6x, dx dx, I didn't write out. And then differentiate 3y, I'm having a 3. And then because we are differentiating y with respect to x, therefore I have to write dy dx at the back. Okay, equals to 4. 4 is a constant. When you differentiate the constant, definitely you will get a 0. Okay, so after the differentiation, it will look something like this. And this process, we call them as implicit differentiation. And now, to get the dy dx, of course, we have to try and factorize out the dy dx on the left. So I'm having 2y plus 3. So move the other terms to the right-hand side. So I'm having negative 3x squared plus 6x. And try to bring everything over. And this is how we get our dy dx. So double check our answer. Okay, so it is exactly like what they want us to show. Okay, then let's proceed to part B. Okay, so for part B, they want us to find the coordinates of the point on the curve where the tangent is parallel to the x-axis. So tangent. When they are talking about tangent parallel to the x-axis, we are interested about the gradient of tangent. So the gradient of tangent, alright, we should know that it is equals to the differentiation of the curve, which is the dy dx at the particular point x. Alright, so gradient is dy dx, and then parallel to the x-axis. When they are talking about the tangent parallel to the x-axis, tangent is a linear line. So parallel to the x-axis means it will be the horizontal line. So for any horizontal line, the gradient basically is equals to 0. So trying to link these two together, we obtain the result where dy dx is equals to 0. We are having this dy over dx equals to 0. What is our dy dx just now? So we are having this negative 3x squared plus 6x divided by 2y plus 3, and it is equals to 0. Okay, so bring everything up. I left only this one. Okay, 3x squared, factorize of the 3x. So I'm having 3x multiplied with x plus 2 equals to 0. So from here, I'm having two coordinate for x. So x can be equals to 0 and also x can be equals to negative 2. Right, so for this question, they're interested about the coordinates of the points. So we successfully get the x coordinate already. So now we need to continue further to get the y coordinates for these 2 points. Right. Okay, so how to get the y coordinates for these 2 points? Okay, so first we let x equals to 0. When let x equals to 0, right, what happened to your original curve? Okay, so your original curve is this one. So if I let x equals to 0, I get something in terms of y. Right, so I'm having y squared plus 3y equals to 4. So go back here. I'm having y squared plus 3y equals to 4. So the equals to 4, I bring it over, become minus 4. Okay, so this is what we have now. When x equals to 0, this is the y equation that we have. Therefore, to get the value for y, we can further factorize it. So I'm having 4 and negative 1, right? So solve it, I'm having y equals to negative 4, y equals to 1. So when x equals to 0, right, it actually gives you two points that has the gradient parallel to the x-axis, gradient or tangent parallel to the x-axis, which is x equals 0, y equals to negative 4, and also x equals 0, y equals to 1. Okay, then for the second point, we are having x equals to negative 2. When x equals to negative 2, what is the y coordinate that we will have? So again, when I'm having x equals to negative 2, refer back to your original equation. This is the original equation, x cubed plus y squared plus 3x squared plus 3y equals to 4. Okay, so maybe I should write down here. Yeah. Okay, so my original equation is x cubed plus y squared, is it? Okay, then plus 3y squared plus 3y equals to 4. This is my original equation. So substitute x equals to negative 2 into the x. So I'm having negative 8 plus y squared plus, sorry, this one shouldn't be 3y squared. This one should be 3x squared. So substitute x again as negative 2. So you're having 4. 4 times 3 is 12. Then plus 3y, you just copy as 3y equals to 4. So I bring the 4 over, become minus 4 equals to 0. Okay, try to simplify the equation. Okay, so you have 3y plus y squared equals to 0. Then further solving this equation here. So we will be having y equals to 0 and also y equals to negative 3. So when x equals to negative 2, we actually obtain another 2 points, the coordinate for another 2 points where the gradient of tangent at these 2 points is equals to 0. So end up there are 4 answers for this case, right? So what are the coordinates that we have? So we are having 0, negative 4, 0 and 1, negative 2 and 0, and also negative 2 and negative 3. Right, so these are the 4 points that will be giving us the gradient of tangent equals to 0 or parallel to the x-axis. Alright? Yeah, so this is how we solve question number 6. Okay, so question number 8. We are given the differential equation. Then we are given the initial value. Then they want us to solve the differential equation, obtain the expression y in terms of x. Okay, so for this question, to solve the differential equation, right, we need to separate our variable, all the y to one side, all the x to the other side. So basically, I'm having the equation like this. For cos square 3y, I want to bring it over. So it will become 1 over cos square 3y. That means I bring it over, become divided. So I keep the dy here. For dx at the denominator, I try to bring it over to the right hand side, become something with dx. Then e power 4x also, I try to bring it to the other side, become 1 over e power 4x. And you can see that we successfully separate our variable to 2 different sides. All the y at one side, all the x at the other side. So after you separate them clearly to each side, right? So you can start the integration. So you can put in the integration sign. Right, then how are we going to integrate all this? So let's have a look for 1 over cos square first. 1 over cos square can be written as secant square. And secant square is a basic function that we can integrate them straight away. Right, and then how about e power 1 over e 4x? So e 4x, I want to write become e power negative 4x. Okay, then from here, this is a basic function that we can integrate them straight away. This one also the same. So in case if you already forget, right, what is the function? What do we get after we integrate secant square? So you can have a look for the simplified version of the integration formula. So like what I told you before also in maybe other videos, the integration formula is provided actually, but they are very, very basic. Okay, so as an example, they only show you how to integrate secant square x, but they didn't tell you how to integrate secant square 3x. So this is the basic function that you get. Integrate secant square, you should get tangent, right? But of course, you need to know the process of integration. So after you integrate this, if let's say you're having 3x here, then your final answer should be divided by 3. Alright, so the process of integration is still very important because the formula booklet only provides us with the very basic integration formula. Alright, so from here I know integrate secant square, I will have tangent. Then how about integrate e power x? So I will get back the e power x. But if we go back to our example here, okay, so integrate secant square 3y. So integrate secant square, I got tangent. So I will have tangent. Copy back the angle 3y and divided by the differentiation of the 3y here. Differentiation of 3y, you get a 3, right? So I have to divide it by 3. So this is something that the formula booklet didn't show. They only tell us that how to integrate secant square x, that you will get a tangent. Alright, but of course you need to know all the details for the integration here. Okay, then after that, same thing happened for the e power negative 4x. So for e power negative 4x, just now we know that integrate e power x, I get back the e power x, right? So same thing happen here, e power negative 4x, I will get back e power negative 4x. And of course, haven't complete yet, you have to differentiate the power, which is negative 4x. So differentiate negative 4x, what do you get? You get negative 4, right? Then plus c. Okay, so from here, what do I have next? I try to simplify the equation first before I want to find out the value of c. Okay, all right, so now we need to find out the value of constant c. So how to find the value of constant c? You need to have the initial value. So your initial value is given here, which is y equals to 0 and also x equals to 2. All right, so when y equals to 0, x is equals to 2. And therefore, our equation will become 1 over tangent 0 equals to negative 1 over 4, then e power 4, right? Substitute 2 into the equation here. Should be e power 8, sorry, e power 8, then plus c. Then from here, you actually get your c equals to 1 over 4 e power 8. Okay, because tangent 0 should be a 0, right? Then you bring this thing over, therefore this is how you get a constant. Okay, so of course, our step haven't completed yet, because our final answer should be y in terms of x. Alright, so now let us rephrase our equation so that it become y in terms of x. Okay, so first I try to rewrite my equation again. Okay, so first of all, what I want to do here is I feels like I want to factorize out the 1 over 4 because there's 1 over 4 in both terms on the right. Then I will want to write become e power negative 8 minus e power negative 4x. So that it doesn't look too complicated. I feel like this looks slightly easier. Okay, if you want to keep it as fractions, still no problem. All right. Okay, then after that, I want to slowly move all the terms or function on the left slowly to the right. So first of all, I want to get rid of the 3, 1 over 3. So the 3 as a denominator, you have to multiply the whole equation by a 3 lah. So I'm having 3 over 4, and then e power negative 8 minus e power negative 4x. Alright, so next, I want to bring the tangent over. So of course, it will become tangent inverse. Then 3 over 4 with the bracket of e power negative 8 and e power negative 4x. Then next one, how to get the y? So y is 1 over 3 tangent inverse 3 over 4. Okay, yeah, so we successfully express the equation y in terms of x. Okay, so this is how we get the answer for question number 8. Alright, so question number 9. We are given the function fx and they want us to express fx in partial fraction. Okay, so first of all, we have to double check and see whether this fraction belongs to a proper fraction or improper fraction. So let us have a look for the degree of numerator. So the degree of numerator, right, the highest power is 2 for the x, therefore it is actually degree equals to 2. And for the bottom one, if you multiply all the x together, the highest power for x is x power 3, right? X squared multiplied with x, I'm having x power 3. And therefore, the degree for the denominator will be equals to 3. And when we are having the degree on top is smaller than the degree at the bottom, so basically this is a proper fraction. So for proper fraction, you can separate them into the partial fraction directly without going through the long division. Okay? Right, so let's start with the partial fraction. Okay, so if you have a look for the bracket at the bottom, so we are having two brackets mainly. So the first one will be 2 plus 3x squared, and another one is actually 2 minus x. So for the first fraction here, right, 2 plus 3x squared, it is a quadratic factor. So for quadratic factor, the numerator will look standard in the standard form of ax plus b. It must be 1 degree lower than the denominator. So our denominator is having a square, right? So the numerator on top should be 1 degree lower, which is ax power 1, then plus b, the constant term. For the second fraction here, it is a linear factor, right? 2 minus x power 1. So for linear factor on top, we are only having a constancy, right? Okay, so now we need to make sure that the whole denominator disappears for the whole equation. So I multiply the whole equation by using I multiply the whole equation by using 2 plus 3x squared and also 2 minus x. Okay, so if you multiply them, then basically our equation will look something like this. Okay, so for ax plus b, 2x plus 3x squared simplify with 2 plus 3x squared, sorry, 2 plus 3x squared simplify with the 2 plus 3x squared. So the ax plus b have to multiply together with the remaining bracket is 2 minus x. Okay, so just want to emphasize one common mistake that students do usually. Don't forget about the bracket for the ax plus b. Yeah? If without the bracket, that means only 2 multiplied with 2 minus x, which is a wrong solution. Alright. Okay, then for the next term here, I'm having c. 2 minus x multiplied with 2, simplify with 2 minus x, you simplify them. So the c remaining is c bracket 2 plus 3x squared. Alright, so what should we do next? Okay, so next one, we want to find the value for a, b, and c. There are many different ways that you can get the answer. So for me, I'm going to use the method where I want to eliminate the unwanted unknown. So first, I'm looking at the linear factor I have on the right. So this is the linear factor that I have, right? 2 minus x. I want to substitute a value of x so that this bracket becomes 0. So that means I have to let x equals to 2. Because if I let x equals to 2, substitute into this bracket, the whole thing here will disappear because of the 0. So I can successfully find the C. Okay, right, so substitute x equals to 2 into the whole equation now. So 2 square, you get a 4. 4 times 17 minus 14 plus 16. So try to simplify the term on the left, you get 70. 2 minus 2, you get a 0. So this whole thing disappear. So 2 square is a 4. 4 times 3 is 12. 12 plus 4 is 14. So you're having 14C on the right. And C is equals to a 5 when you simplify them. Okay? Alright, then now let's decide the second value so that something will disappear. So the other linear factor that we can use is this one, ax. What should you substitute into the x so that a will disappear? So you have to let x equals to 0. Okay, so when you let x equals to 0, all the left hand side here left only 16, right? Okay, so 0a means 0. 2 minus 0 means 2. So 2 times b. So for the right hand side, you're having 2b here. X is a 0, so you're having 2c. So what's the value for c just now? 5. So 2 times 5, you get a 10. Therefore, from part B, for this part, the b value that you get should be equals to a 3 after you simplify them. Alright, so you can see that we successfully get the value for C and B. Now we want to get the value of A. Then again, on the right hand side, we try to observe, is there any linear factor or not? So you can see that there's no more linear factor. This is actually quadratic factor. So we are only focused on linear factor first. So there's no more linear factor. That means for the last value, if you want to get the value of A, you can use any value that you never used before. So maybe for me, I want to use x equals to 1, the smallest value that I never used before. Okay, I used 0 already before. I used the 2 already before. So now I want to use x equals to 1. So when x equals to 1, substitute into the whole equation here. 17 minus 7 plus 16. So I should have 26. Okay, then equals to, when x equals to 1, I'm having a 1 here. So 1 plus b. 1 plus b means 1 plus 3. Oh, sorry, it should be a plus 3. Sorry, a plus 3 times 1. So this whole thing is a plus 3. Okay, after that, substitute 1 here. You're having 3 plus 2 is a 5. 5 times c, you got 15. Sorry, 5. Again, you want to substitute x equals to 1, right? So 3 plus 2 is a 5. 5 times 5, sorry, 5 times 5 is 25. Not 15 plus 25. Okay, then again, you can slowly simplify your equation. By right, you should have a equals to negative 2. So we successfully get all the value for a, b, and c here. And now we can rewrite again in the complete form of the answer, where your 17x squared minus 7x plus 16 over this one, okay, is equals to ax plus b. So I put the positive value first as I'm having 3 in front, then minus 2x divided by 2 plus 3x squared. Okay, then plus c. c is 5, so it should be 5 over 2 minus x. So this is the partial fraction that we get. Usually I would prefer students, or maybe I will remind students, try to write again in a complete form like this. Okay, after you successfully found the value for a, b, and c. Alright, yeah, so this is how we get the partial fraction. So let's continue further to the second part B. Okay, so for part B, right, they want us to obtain the expansion of fx in ascending power of x up to and including the terms in x power 3. Alright, so when you see this kind of question, basically they are talking about binomial expansion. Okay, so is the binomial expansion formula be provided in the formula booklet? Yes. So it is in second page here. So there are two binomial series or expansion formula here. One is for AS, another one is for A2. So of course we are using the second one. All right, so maybe I can, you can try to remember this one. Okay, I try to copy it just now, and let's paste it here. Okay, so this is how the equation looks like. So in case you can't remember, then you can try to refer. All right, you can try to refer. Sorry. Okay, so let's have a look. Okay, all right. So if you have a look for the binomial expansion formula, right? It must be in the bracket form, and then I need to emphasize that you have to have a look for this one. Okay, the first term here in the bracket must be a 1. If you want to apply this formula, must be a 1. Okay, all right. So now to expand the fx, I want to use back my result in first part just now, part A, where I successfully get my partial fraction, right? Partial fraction. So I rewrite it as partial fraction first. Okay, so this is what I have as a partial fraction. Okay, so to apply, okay, to apply the binomial expansion or binomial theorem on these two fractions, I need to rephrase my fraction become something in power. So if I want to rephrase it, right, I copy the numerator on top. The denominator at the bottom, I will want to bring it up, become power negative 1. Same thing happen for the second fraction here. So the 2 minus x, I want to bring it up and it will become power negative 1. Okay? Alright, then what is the next step? So like what I told you just now, according to the formula here, the first term in the bracket must be starting with a 1. So both my equation, okay, both my bracket does not start with a 1. Therefore, what I need to do is that I have to take out the 2. When you want to take out the 2 from the bracket, don't forget about the power. The power must follow together. So you're having 2 power 1. So when you factorize out the 2, right, the first term in the bracket become a 1. The second term, you need to divide it by 2. So that when you multiply the 2 go back into the bracket, so they will get back the 3x squared. So now it will become 3x squared over 2 because I have taken out 1, 2 from the bracket. So I'm having negative 1 here. Okay, so you can see that I try to do some small adjustment so that my bracket here, the first term of the bracket started with the 1. Okay, then do the same thing for the second bracket. So I'm having here, then 2. I want to factorize it out and therefore I'm having 2 power negative 1. Okay, so this one should be 2 power negative 1. Okay, then after you factorize the 2, I'm having 1 minus x over 2 power negative 1. Okay, all right. Then again, for my practice, right, before I do any expansion or apply any formula, I prefer to simplify my step first before I continue to the next step. So I want to simplify this whole part here. I'm having 1 over 2 multiplied with 3 minus 2x power 1. 3 minus 2x power 1, because it is power 1, there's no point for us to expand anything. We will just keep it and remain it as 3 minus 2x first. Okay, then for this one, I'm having 1 plus 3 over 2x squared power negative 1. For the term at the back, I'm having 5 over 2, then 1 minus x over 2 power negative 1. Okay, so next step, I will start to expand my bracket using binomial expansion formula. Okay, so first of all, I'm having the blue color one. I draw this in the blue color. To expand this one, what am I going to do now is, I try to apply the formula because the first term already started with 1, right? For this bracket, my n is negative 1. N is the power, right? So you can observe that n is negative 1. What is the x in the formula? The formula is having the x, but in my equation here, the x will be replaced by 3 over 2x squared. So if I try to expand it, first term is a 1, so you copy as a 1. Second term is n times x. So n times x means that you're having negative 1 multiplied with 3 over 2x squared. This is my n. N is negative 1. x is 3 over 2x squared. Then what's the next term? So the next term should be something and then x squared. So let's have a look. If let's say I'm having our x, which is 3 over 2x squared, right? If you square again, you're having x power 4. Right? You're having x power 4 for the next term. But in our expansion here, they are only interested until x power 3. So we'll just stop here. We are not going to continue to get x power 4 anymore. Alright, because the question requested for x power 3 only. Okay, so for the first blue bracket here, we only expand for the first two terms, 1 plus nx. Because if you continue with n minus 1 over 2 factorial x squared, you'll get something with x power 4, where it is not needed in our solution. Okay, then let's continue to the second bracket here. So plus 5 over 2. So I just copy as 5, plus 5 over 2. Okay, so now I'm going to rephrase it by using a green color. So this is a bracket that I want to expand. So how can I expand it? So again, n is power negative 1, n is negative 1. The x is negative x over 2 for my question. Okay, so first term is 1, so you just copy as a 1. Second term is nx, so n, x is negative x over 2. Okay, then plus next term is n minus 1 divided by 2 factorial. So your n is negative 1. N minus 1 is negative 2 divided by 2 factorial. Okay, then x squared. So for the x squared is negative x over 2 and then square. Right? Okay, so this is something with x squared. Then for our question, they requested for x power 3 ma, so you have to continue further. For this one, n minus 1, n minus 2 divided by 3 factorial, then x power 3. So I'm having n, which is negative 1, n minus 1 is negative 2, n minus 2 is negative 3, divided by 3 factorial, and then x power negative 3, x power 3, so negative x over 2 power 3. So if you continue further, right, if you continue further to expand one more term, it will be in terms of x power 4, and where we are not interested for x power 4. Therefore, for this second expansion here, we'll stop at x power 3. Okay, so this is how our solution look like. And of course, you need to further simplify it, okay, to get the simplified answer. Alright, so now we try to simplify the blue color bracket. Okay, so when I try to rewrite in a better way, last I'm having 1 minus 3 over 2x squared. Okay, then for the green color part, again, I try to simplify them first. So if I want to simplify them, you can use calculator to help you, of course, alright? So you're having 1 plus half x. You double check and see whether you get the correct answer or not, yeah? So 1 plus half x, then plus 1 over 4x squared, and also 1 over 8x power 3. Okay, so try to press calculator, make sure that you don't miss out any negative sign with the power. So when you're having any negative sign with the power, you have to put a bracket when you press calculator. Okay, so next, what should we do next is, we are trying to expand the bracket. So for the first term here, right, for the first part of the expansion here, you need to expand the bracket. 3 multiply with 1, 3 multiply with this, okay, then 2 multiply with 1. So for me, I will ignore 2x multiply with 3 negative 3 over 2x squared, because if I'm having x multiply with x squared, oh sorry, I need to consider also because we have x power 3, right? Sorry for that. So you have to expand it also, so that you get in terms of x power 3. Okay, if you expand it without doing any careless mistake, so by right you're having 3, then minus 9 over 2x squared, then minus 2x, then plus 3x cubed. Okay, so if you expand it correctly, so by right this is what you should see, or you should have. Alright, then for the second part here, okay, so you just try to multiply in the 5 over 2. So you're having 5 over 2, then plus 5 over 4x, plus 5 over 8 x squared plus 5 over 16, right? X power 3. Okay, then next one. Next term, we are going to multiply in all the half into the first bracket. Okay, so if you multiply in the half, right? So you're having 3 over 2, 9 over 4, x squared, then x, then 3 over 2, x cubed. Okay, then next step is, again, you can try to group all the x together, all the x squared together, and also all the constant term together. All right, then you can try to sum up together this one. So 3 over 2 plus 5 over 2, you get 8 over 2. So 8 over 2 divided by 8 over 2 is a 4, right? Then for the terms in x, negative x plus 5 over 4x. So by right, you're having 1 over 4x. For the term x squared, negative 9 over 4x squared plus 5 over 8x squared. If you didn't do any careless mistake, by right, the calculator will give you negative 13 over 8x squared. Then the last term, 3 over 2 plus 5 over 16. So if you didn't do any careless mistake, by right, this one is the 29 over 16. Okay, yeah, so this is what we have for the binomial expansion up to the x power 3 terms. Okay, all right, so the step might be slightly tedious, all right, but just make sure that when you expand everything, please expand it slowly and avoid careless mistake. All right, right, then after that, for part number C, they want you to state the set of values for x where the binomial, the expansion in B is valid. Give your answer in exact form. So they want to find out the valid value for x when we are doing the binomial expansion. So let's go back to what we have. Okay, so they are actually mentioned in the formula booklet as well. When you want to apply this binomial expansion formula, right, they are giving you the condition where the modulus x must be smaller than 1. This is provided in the formula booklet. So that means the valid value for x, okay, in this binomial expansion is modulus x smaller than 1. How to get the modulus x smaller than 1? That means they get the modulus of the term behind smaller than the value in front. Okay, so this is how they get it. All right, so let's have a look for our equation for our expansion here. For the blue color one, right, maybe I put it here, yeah. For the blue color one, I want to have modulus of the terms at the back smaller than the number in front. Okay, and then for what we have here, we are having modulus x squared. Bring the number over, become 2 over 3. Okay, therefore your modulus x should be between the value of plus minus square root 2 over 3. That's for blue color bracket. And then for the green color bracket, if I want to get the valid value of x, it should be modulus negative x over 2, smaller than 1. So modulus will make the negative disappear, and I want to bring the 2 over, so it should be x smaller than 2. Okay, so we are having two answers here, right? So by right, to make sure that our expansion is valid, we need to choose the smaller set of x so that it is valid for both set of the bracket for binomial expansion. So we choose the smaller set. Which one is the smaller set? Is it x smaller than 2 is smaller, or this one is smaller? For modulus x smaller than 2, right, the meaning is it is between negative 2 until positive 2. Then for the blue color one, actually the meaning is it is between square root 2 over 3 until positive square root 2 over 3. So I think the answer is quite obvious, right? So the smaller set is actually this one. Therefore, this will be our valid value for x to make sure that the binomial expansion is correct or valid for both bracket, right? Yeah, so this is how we decide it. Therefore, the final answer for this part will be negative square root 2 over 3 until positive square root 2 over 3. You can write in this form, or some students might prefer to write in the form of modulus x. So if you want to write it out in modulus x, it is actually between modulus x between, modulus x smaller than square root 2 over 3. So it can write either way or either form for this part of the answer, for the answer of this part. Okay. Yeah, so please make sure you know also how to decide the value for x for the binomial expansion. Okay, yeah, so this is how we solve the question number.
Okay, so we are now at question number 10. We are given a diagram and then it shows the curve y cos 2x, y equals to x cos 2x for the x greater equals to 0. They want us to find the equation of the tangent to the curve at the point x equals to pi over 2. Okay, so when we look at the keyword, equation of the tangent, right, we should try to link the gradient of tangent, and the gradient of tangent basically is equals to dy dx. Right, so for this particular question, you have to start with the dy dx first. Okay, so we'll start from here. Okay, I'm having y equals to x cos 2x. Okay, so this kind of function basically is the product of two different functions. The first function is x, the second function is cos 2x. So it is a product of two different functions. So to find the differentiation for the product of two different functions, right, basically we have to apply product rule. So product rule means if you can't remember the formula, you can have a look for the differentiation part. And then I think this is what you can see. Okay, this is the product rule that we have. Okay, so that means uv is the function. U is the first function, v is the second function. So if you have a look for the formula here, you can see that you copy the second function, differentiate the first, plus then you copy the first function, differentiate the second. Okay, so we'll apply it here in our question number 10. Okay, so for those who can't remember, maybe you can refer to what we have here, right? The formula. Okay, so let's start. I want to find out dy dx. Now I copy the second function. So copy the second function is cos 2x. Differentiate the first. So differentiate the x, you're having a 1. After that, you copy the first function, which is the x. Then you differentiate the second function. So when you differentiate the second function, differentiate cos, you have negative sign. Copy back the angle. And after that, differentiate the thing inside the angle. So differentiate 2x, you'll get a 2. Okay, so you can try to rephrase your equation here. So I'm having cos 2x, then minus 2x sine 2x. So basically, this is what we have for the dy dx. Alright, and now we want to know what is the gradient of the tangent when x equals to pi over 2. Therefore, you have to substitute x equals to pi over 2, okay, into the dy dx to get the gradient. And besides, also, I need to find out the coordinate of y so that I can use this point, this coordinate, to find out the equation of the tangent. So how to find the equation, the value of y? Basically, you substitute into the original equation here. So I'm having pi over 2, then cos 2 times pi over 2. You're having a pi. Okay, so cos pi over 2, you're having cos pi. So cos pi actually give you a value negative 1. Eventually, your y is having negative pi over 2. Alright, then after that, we want to get the value for dy dx. So which is the gradient of tangent. Right, so how to get the value for dy dx again? Substitute x equals to pi over 2 into your dy dx just now. So you're having cos pi minus 2 times of pi over 2, then sine pi. Alright, so what's the value for cos pi that we have? We are having negative 1. Okay, then minus pi. What's the value for sine pi? It is equals to 0. So when you try to simplify this particular value for dy dx, it is equals to negative 1. So please take note that this negative 1 is the gradient of tangent. Okay, and then the coordinate for x and y is pi over 2 and also negative pi over 2. So we have passing point, we have the gradient of the line, therefore we can form the equation of the line. So how to form the equation of tangent? Okay, so I'm using y minus y1 equals to mx minus x1. Right, so tangent should be a linear function, right? So y minus y1 means that y minus the y coordinate equals to m is negative 1, then x minus x coordinate, which is pi over 2. So try to simplify this particular term here. I'm having negative x plus pi over 2. So if you further simplify this equation, you'll see that your equation of tangent should be y equals to negative x. So this is how we solve the question. Okay, then let's proceed to part number B. Okay, for part B, they want us to find out the exact area. Please highlight the word exact. This tells you that your final answer should be in the third form, pi form, and it shouldn't be in the long decimal number. Okay, and they are asking for the shaded area, the exact area of the shaded region in the diagram, bounded by the curve and also the x-axis. So again, to set up the steps to find out the area, we need to have a look for the graph. Okay, so the graph shows us very clearly that this is the area that we want to find. And the area start at the point 0 and end at this point. So how to find this point? I want to know the coordinate for this point. Therefore, I have to let y equals to 0. Then you find out x. Alright, so I know that the area is covered start from 0 until this particular value. After that, only I can further set up the step to find the area. Right? Okay, so first we will need to let y equals to 0 to get the value for x. So I'm having this original equation, x cos 2x. So when I let y equals to 0, I'm having two equation for solution. So I'm having x equals to 0. Another one, I'm having cos 2x equals to 0. So this 0 is very obvious. It is already shown in the graph just now, right? You can see that the area starts from x equals to 0. And then now I want to know what's the value for the x. Okay, so cos inverse 0, you try to get cos inverse 0. By right, you're having pi over 2. Then if you want to go further, it will be 3 pi over 2. So if you can't really remember how to get the pi over 2 here, you can use calculator to help you. You press cos inverse 0, or you can refer to the original diagram for the cos. In my opinion, right, the original graph of cos and sine actually is very important. Right, so I'm having a cos graph like this. So to get cos equals to 0, it will be at these 2 points here, where it should be pi over 2 and also and also 3 pi over 2. So for me, I only want the very first x-intercept, right? Therefore, I only consider one answer here, which is 2x equals to pi over 2. That means you take cos inverse 0. And after that, we bring the 2 over. I get x equals to pi over 4. Okay, all right. Then now, we have to set up the step so that we can find out the area. So how to get the formula for the area here? Basically, it involves integration. So I'm having integration. The limit for the x should start from 0 until pi over 4. Because like what I showed you just now from the diagram, the area start at 0, x equals to 0, and the area end at pi over 4, x equals to pi over 4. And then it is bounded by x-axis, therefore you can put it as dx. Then what's the function that we have here? It is actually x cos 2x. Okay, so now, just now we are having differentiation, right? Because it is the product of two different functions. Therefore, we use product rule for the differentiation. And same thing happen here. This is the product for two different functions. If we want to find out integration, we have to use integration by part. Okay, so there's a certain formula for you to follow, right? How to find out the integration by part. Generally, it is like this. Integrate u dv equals to uv minus v du. So generally, this is what I have, right, for integration by part. If you can't remember the formula, you can also refer it, okay, from our formula booklet under the integration part. Then you can have a look for this one. This is the integration by part formula. For this formula, right, in the formula booklet, it looks much more complicated than what I show you, right? Okay, so basically they are the same actually, just that I try to erase the dx and also the dx. Therefore, I'm having integrate u dv equals to uv minus v du. Again, I cancel off the dx and dx together. Alright, so my formula at least looks slightly simpler compared to what we have here. Alright, so basically this is what I use. They are actually the same, just I cancel off the dx and dx. Okay, that to me is quite confusing, right? Or maybe it makes the equation looks very complicated, alright? So, okay, so we come back to our formula here. Okay, so to find out the answer for integration by part, right? Actually, there's some rules that you have to follow, where we call it as Lyot's rule. Okay, the L, okay, is included recently because after year 2020, it is because of we started to bring in the tangent inverse function in, okay, in the integration. Therefore, we have to include it in our rules here. So what's the meaning for L? L means logarithmic function or ln function. Then I means inverse function, inverse trigo. Sorry, inverse trigo function. In our syllabus, only tangent inverse is involved. Okay, A means algebra. Algebra means all the polynomial x square x 2 all the numbers are also algebra. Then for T will be trigo, and the E will be exponential function. Okay, so if your function belongs to the higher group, then it will be U. If your function is at a lower group, then it will be dv. Okay, so let's have a look for our function here. I'm having x cos 2x. Again, x is the group algebra. Cos 2x is under the group of trigo. Okay, and you can see from here, right? You can see from here, basically what we have is we are having A is the higher group, trigo is the lower group. Therefore, the higher group will make it as U. So that means I will let U equals to X. Okay, then how about the T? So T is the lower group, right, which is trigo. So I will let dv equals to T. So I'm having dv equals to cos 2x. Okay, so you can still see there's a dx at the back of the equation, so I just keep it as dx. So after you set up the question correctly, then you just put the integration sign. So the integrate dv here actually should have a 1, right? It has a number. So integrate dv equals to integration of cos 2x dx. Right, so after you decide the group already, so for this part, please apply differentiation. So u equals to x, then du dx equals to 1. And therefore, du is equals to dx. Okay, integrate 1 dv, I'm having a v here. Integrate cos 2x, I will have sine. Then 2x. Differentiate the thing inside the angle, which is 2x. Differentiate 2x, you get a 2. So in integration, you have to divide it by a 2. Okay, yeah, so this is my v after the integration. So for me, I'm not going to put a plus c at the back here because this is not my final step with the integration yet. So I will just keep until last step only I add in the c. Okay, so this is what we have by setting up the integration by part. Right? Then now I'm going to apply our formula. So integrate u dv is the question equals to, so after you set up the u and also the dv, right? So now you have to take uv. So what is u? In our solution just now, u is equals to x. So you take x multiply with v. What is your v? So it is actually sine 2x over 2. So this is what I have for uv lah. So after you put in the uv, you have to substitute in the limit as well, which is pi over 4 and 0. Then minus v du. So what is my v just now? I'm having this sine 2x over 2. Oh, yeah. So before I forget, also don't ignore this one. Yeah, your limit is still the same, which is 0 until pi over 4. Okay, then your v is sine 2x over 2. Okay, then du. What is my du? So go back to this side. Du is equals to dx. Okay, yeah. So this particular formula basically is uv minus integration of v du. Okay, so next step, I have to try and substitute pi over 4 inside and also the 0 inside. If I substitute pi over 4 in here, I'm having half multiply with pi over 4, then multiply with sine. 2 times pi over 4, I get pi over 2. Then minus, substitute the 0 into the phrase here, I'm getting whole thing 0. Okay, then for the second part here, I take out the constant half. And now I start integrating the sine 2x. So integrate sine 2x, I will get negative cos 2x. Then after that, I have to differentiate the angle, okay, inside the trigo. So the angle is 2x. Differentiate 2x, we're having a 2, right? So in integration, you have to divide it by 2. Okay, so again, I'm having the limit pi over 4 and also 0. Okay, next step. Trying to simplify my answer here. So I'm having pi over 8 sine pi over 2 give you a value 1. Okay, then for this part, before I substitute in the value, I prefer to take out all the constant first, where it should be 1 over 4. Okay, it should be 1 over 4. Then now I want to substitute pi over 4 inside the function, so I'm having cos 2 times pi over 4, I'm having cos pi over 2. Then minus, substitute 0 inside, I'm having cos 0. Okay, then again, further simplify our answer. What is the value for cos pi over 2? It should be a 0. What is the value for cos 0? It is a 1. Okay, and this is what we have. Pi over 8 minus 1 over 4. So I will keep my answer in this form so that it is actually the exact area for the shaded region shown in the diagram just now. Alright, yeah, so this particular method, we call it as integration by part. Alright, so I hope that you know the rules, okay, and also the detailed steps to set up the solution. Okay, yeah, so this is how we solve question number 10. So the last question for this paper, question number 11. So we are having the line L, and then the vector equation for line L is given like this. The point A and B have position vector as shown. Okay, so first they want us to find the unit vector in the direction of L. Okay, so we need to know what is the direction of L. Basically, for any vector equation, right, the general formula is R equals to A plus TP, where the T is an unknown or maybe a variable, a value, all right, but that we still don't know yet, so it's unknown. Okay, so what's the meaning for A? A is the passing point along the line, okay, that lies on the line. Then P basically is the direction of the line. So they're asking for the unit vector in the direction of L. So first of all, we have to figure out which is the direction of the line L. So lambda is the unknown, right? So this particular vector here will be the direction of L. Okay, then how are we going to find out the unit vector? Right, so to find the unit vector, basically there's a formula to follow where the formula is unit vector equals to original vector divided by the magnitude of the original vector. So basically you need to just divide it by the magnitude of itself, right? Okay, so I know that maybe for me I prefer to let it equals to P lah. P is the direction of the line, which is -1, 1 and also 2. So now I want to find out the modulus of this direction. So what's the modulus for this direction here? So it is actually a square plus b square, then plus c square square root, right? Okay, so if you didn't do any careless mistake, by right it is 6. And now only I can find out the unit vector of this p. Okay, so again, according to the formula, it is the original vector divided by the magnitude of the vector. So what is my original vector here? -I plus j plus 2k. Then divided by the magnitude, so it should be square root 6 divided by square root 6. So please separate it clearly into the 3 different components in ijk. So I'm having -1 over square root 6i, then plus 1 over square root 6j, and also 2 over square root 6k. Okay, so this is what we have as a unit vector of the direction of L. Okay, so just in case, if let's say you doesn't prefer to have your answer with a sub form at the denominator, then you can rationalize it. If you are going to rationalize it, basically it should be negative square root 6 over 6i plus square root 6 over 6j and also square root 6 over 3k. Alright, so if you rationalize your answer, basically it is also accepted. Yeah, so this is how we find out the unit vector for a particular vector. Alright, okay, then let's proceed to part number B. For part number B, they are saying that the line M passed through the point A and B. So they want us to find a vector equation for M. Okay, so I'm having line M pass through the point A and also B. Okay, so to form the vector equation, I need 2 things. The first one is the passing point. And the second one will be the direction of the line, or we call it as gradient of the line, but in vector we call it as direction of the line. Yeah, so I need 2 things, passing point and also direction. So M has passing point A and B, therefore the passing point is more than enough. Alright, so we just need 1, but they already tell us that we have 2 here. And then we need to know the direction of the line. So to get the direction of the line, basically you can see that the direction can be A to B or can be B to A. They didn't mention anything about what direction, right? So the direction of the line can be A to B or B to A. So first step, let us find out the direction of the line, which is AB. So again, if you want to find BA, also no problem. So what is AB here? AO plus OB. So if you have a look for A, this is your A. This is OA. Okay, OA is -2, 2, and -1. So I want to get AO. AO means you change the sign for this vector. So it will be 2, -2, and 1. So I'm having 2, -2, and also 1 here. Okay, so this is AO plus OB. So what's the OB that I have? So you directly copy what you have here. This is basically the OB. 3, -1, and also 1. So 3, -1, and also 1. Here you are getting 5, then -3, and also a 2. Alright, so this is a direction of the line. Okay, then if I want to find out the vector equation of M, okay, so what should we use? So like what I showed you just now, R equals to A plus TP. A is the passing point, P is the direction of the line. So I want to apply in what we have for this example or this question. So R equals to A. A is the passing point. So you can use AO, you can use OA or you can use OB. Alright, so my direction start from A. Right, so for some reference book, they prefer to have OA, then using the direction AB. Okay, so what is OA? So the OA will be negative 2, 2 and negative 1. So you can write as negative 2, 2 and negative 1. Then plus T, then P. What's the direction of the line? So AB is the direction of the line. So you can put it as 5, negative 3, and also 2. Okay, so this is generally what we have for this particular equation. But please take note that the vector equation, right, for a particular line is not unique. That means for this direction, it is not wrong if you make it become negative 5, 3, and also negative 2. Okay, you will get this vector if we are using B to A. For this one, I'm using AB, right? From A to B. So if you use B to A just now, then this is particularly your answer for B to A. So both are accepted in the solution actually. Okay, then how about for the passing point here? So for the passing point, for this example, I'm using passing point A. Of course, some students might want to use the passing point B. Therefore, if you replace it by using 3, negative 1, and also 1, it is also correct. Alright, so for this particular question, the answer, the solution is not unique. So they accept also slightly different the sign, okay, the opposite sign with the direction of the line. And then for the passing point, you can use either OA or OB. Alright, yeah, so this is how we solve part number B. Okay, so let's continue to part C. Okay, so for part C, they ask us to determine whether the line L and also the M are parallel or not, or are they intersect or are they skewed. Okay, so to check the line whether are they parallel, intersect or skewed, right, there are some process that you need to go through. So first we need to check whether are they parallel or not. If they are not parallel, then we proceed further to decide whether are they intersect or skewed. Okay, so maybe let us find out or write out the line L equation first. So what is the equation for the line L? Okay, so for line L, the equation just now, the vector equation just now is R equals to, I prefer to make it become the column vector form, yeah. So I just help you to recall a little bit. So the L, the vector equation for the line L looks something like this. 1, negative 2, negative 3, then plus lambda. Okay, then I'm having negative 1, 1, and also 2. This is a line L. And then for the line M, the vector equation looks something like this. So what I find out just now is I'm using negative 2, 2, and negative 1, then plus T, 5, negative 3, and also 2. Okay, so first, to check whether the line L and M are parallel or not. So now we are at the first stage. We want to decide whether are they parallel or not. Let us have a look for the direction of the line. Okay, so the direction of the line L, like what I told you just now, it should be negative 1, 1, and also 2. Okay, then the direction of the line M, I will make it become vector Q. So Q is actually this one, 5, negative 3, and also 2. To decide whether are they parallel or not, so you just have a look for the direction of the line and just try to conclude whether they are multiple of each other or not. So very obvious it is not, they are not multiple of each other, right? So you can write that P is not a multiple of Q. Okay, therefore, line L and M, line L and M are not parallel. Okay, so just in case some students might ask, what's the meaning for P is not a multiple of Q? Okay, so just a very quick explanation. If let's say P can be written as 2Q, right? Can be written into this form, then basically P is a multiple of Q. So you can see that if you compare the vector P and also the vector Q here, the direction of the line, they cannot be written in any form of this one, p equals to 2q or maybe p equals to 1 over 2q, cannot. Alright, so that's why we can observe directly that, and we know that p is not a multiple of q. So when p is not a multiple of q in the vector equation, right, generally they will tell us that these two lines are not parallel. Okay, so that means from here I already know, okay, these two lines are not parallel. So you have to proceed further and double check, are they intersect or are they skewed? Okay, so to check whether are they intersect or are they skewed, very easy. We are trying to equate the two equations together. So that means I let this equation equals to this one. Okay, so for the vector equation of line L, I'm having 1 minus lambda, negative 2 plus lambda, and also negative 3 plus 2 lambda. So I try to group them into whole column, okay, whole column vector. Alright, then for the equation, vector equation of M, also the same thing. I combine this whole thing together. So I'm having negative 2 plus 5t. Okay, then 2 minus 3t, and also negative 1 plus 2t. Okay, then what we are going to do next is we are trying to find the value for lambda and also the t. Therefore, we need actually two different equations from here. Alright, so the first equation that we are going to use is, I'm going to use this one, 1 minus lambda, and also equals to negative 2 plus 5 lambda. So 1 minus lambda equals to negative 2 plus 5t, sorry. Okay, so from here, I want to rephrase it in terms of lambda in terms of t. So lambda is equals to 3 plus 5t. And I will make this as the first equation. Okay, after that, I want to use the second equation. Negative 2 plus lambda equals to 2 minus 3t. Okay, so negative 2 plus lambda equals to 2 minus 3t. So again, make it lambda in terms of t. So I'm having 4 minus 3t. And this is my second equation. Okay, then after that, I want to get the value for lambda and t. So I think it's very straightforward. You need to solve them simultaneously. I will let 1 equals to 2. So 3 plus 5t equals to 4 minus 3t. Then 8t is equals to 1, right? If I'm not mistaken. Did I do any careless mistake here? Let me check again. Okay. Is there any, oh, okay, I saw one mistake here, right? This part. When I'm trying to move the lambda over, so I move the lambda over here, so the 5t I also move it to the other side, it should be minus. Okay, so sorry for this confusion here. So let us continue again, yeah? So by right, I'm having 3 minus 5t equals to 4 minus 3t. Then I'm having 2t equals to negative 1. Correct? Because if you bring the 5 over here, right, then 4 over here, then you're having 2t equals to negative 1. And from here, I'm having t equals to negative 1 over 2. After you get t equals to negative 1 over 2, substitute the value into either equation number 1 or equation number 2 to get a lambda. So if you didn't do any careless mistake, by right, your lambda is equals to 11 over 2. Okay, so now I successfully get the value for lambda and also the t. Okay, if the lambda and also the t, right, when I substitute into the third equation, okay, the left hand side and right hand side are having the same value, that means it is intersect. If you substitute t and also the lambda into the third equation here, and you realize that left hand side not equals to right hand side, then it will be, the line will be skewed line. Okay, yeah, so now we have to double check and decide the final answer. Okay, so for checking part, I will write it here also. Okay, so I will take the third equation that we haven't used just now. So left hand side of the equation is negative 3 plus 2 lambda. Okay, so negative 3 plus 2 lambda. What's my lambda here? So 11 over 2. Okay, so again, I will get the value 8. Then after that, for the right hand side, I'm having -1 plus 2t. So -1 plus 2 and then t. T is -half. Okay, so if I substitute in the value everything, I get the -2. So from here, you can see that your left-hand side is not equal to the right-hand side. That means the value of t and also lambda, right, is not correct for all the three equations. That means they are not intersect. If intersect, that means all the values should be the same. Alright, when you substitute it into all the equations here, the left-hand side should be equal to the right-hand side. But now if I use the third equation to check, right, left-hand side is not equal to the right-hand side. Therefore, the line L and also the M are skewed. So they are skewed actually. They didn't touch each other. So it belongs to the skewed case. Okay. Right. So basically this is the process how we carry out to decide whether the two lines are parallel to each other, or are they intersect with each other, or they are skewed to each other. Alright. Then for this question, you can see that when we are checking the third equation that we haven't used just now, the value for left-hand side not equals to right-hand side. So the line L and M are skewed. If they are equal to each other, that means the line L and M intersect, okay, each other. Alright. Yeah, so this is how we solve all the question in this paper. Alright, so thank you very much for watching the video.